Welcome to Alchemy Wizard. I'm Tom, and let's talk alchemy. Today, we're going to talk about my part 3 short on laser ablation. And you guys haven't seen it, I will put a link in the bottom of the video for it. This is the rig right here. We got lasers on top and a little bit of liquid on the bottom. And what I did was put a little piece of magnesium in there, and I successfully took the 4 lasers, focused them into a focal point on the magnesium, and was able to create a very small colloidal, which is hard to see in the camera, but I can show you the video of the colloidal up here. It's about 5 parts per million, not much of a colloidal at all. I mean, the lasers, they only lasted about 10 minutes, so I had to actually recharge them 4 times in order to get 40 minutes of concentrated power on there. I am going to experiment some more with it to see if I can get this little bit of solution, magnesium solution, from 5 parts per million, maybe up to 10. We'll see what happens. The interesting thing about the ablation method with magnesium is one of the metals that I have a tough time creating colloidals with. Now, there are 2 ways to create colloidals. Well, now 3 with the ablation method, the laser ablation method. I have low voltage electrolysis and I have the plasma arc. None of those methods produce anything more than 10 parts per million colloidal magnesium, and sadly to say, the magnesium doesn't last. Within 3 weeks, it's pretty much starts to untangle itself, and so it's been a bit of a problem. The problem with magnesium is it's really reactive in water. If the magnesium's coming off here and being dissolved as an ionic, it becomes an ionic before we can turn it into a colloidal. Well, then we're not going to have colloidals. And I think that's the problem that we have, is that even though we're bouncing this with electricity or plasma arc, it's not forming colloidals fast enough. And so we get a very low colloidal count. Now, what I was kind of excited about here with this method here is it created really stable colloidals. You can look. I can usually tell what a thing I've talked about in shows before is exploding colloidals, and you can tell that a solution isn't going to be too stable if it's got a lot of these colloidals that explode. I'll dig up some footage of exploding colloidals and show you what they look like on the laser microscope. And they literally are being pulled apart and then sucked back together again by the van der Waals forces. But eventually, if we got an exploding colloidal situation, eventually the colloidals explode. They lose their content and become ionic. So that's the problem with magnesium, long-term wise, and getting a high potency of magnesium. I've really been unable to get anything over 10 or 12 parts per million magnesium and have it last. But I think the laser ablation method may provide us with just the right amount of heat and temperature and to create more colloidals. But it's more investigation is in order. And the problem is these lasers, even though they're more of the higher calorie power lasers, are still not really strong enough. I tried it on a silver coin. I don't have it here. I tried it on a silver coin and it didn't work. The melting point of silver is higher than the melting point of magnesium. I was hoping we could get it to work with silver, but I couldn't. But it looks like the melting point of magnesium was just enough that we could create some colloidals from this thing. That said, more powerful lasers would really be helpful. The other thing is getting 4 lasers focused in that one spot is not easy to do. This rig I have to work on. In order to make it even useful, this all has to be secured. See how wobbly this stuff is? This all has to be secured tightly, and then the adjustments made on each of the lasers so that it just stays perfect. Now, I didn't do all that because I just wanted to see if the experiment would work. And so the experiment seems to work. So in the future, I don't know what I'm going to do with it. That being said, I mean, it's still impressive that we can take 4 $10 lasers. Actually, I think they were on sale for Christmas, but I think they're $20 lasers. 4 $20 lasers, and create a colloidal from it. There's a step-up laser, which is the laser where you get this hair off your skin, a skin laser. Those are about $80 a piece. I have to check on the power rating of those things. I don't know how much more powerful they are over these green ones, and maybe I can get away with 2 of those, in which case that would only be about $200 investment in lasers. I don't know. See what happens in the new year. But I just want to wish everybody a Merry Christmas. And thank you for visiting my channel, for subscribing, for recommending my channel. And for those of you that purchase colloidals from the Nano Store, thank you very much for that as well. Every little bit helps to fund the research and keep me going with all of the things going on here. I'm Tom. This is Alchemy Wizard. I will talk to you again soon. And don't forget, yes, you earned a cool by getting to the end of the video, and I really do appreciate it.